Hi, and welcome to the second of 4 videos for section 10.7. In video 1, we looked at the distinct linear factors in the denominator. Option number 2, or possibility number 2, is the denominator has repeating factors. I should say, just say linear, repeating factors. Yeah. So, when we have this situation, our P of x over Q of x gets broken out as follows. A1 over AX plus B plus A2 over AX plus B squared plus A3 over AX plus B to the third, etc., 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 for however many times the factor repeats. So if I have AX plus B to the fifth in my denominator, I would need A4 and A5. So let's look at an example. So let's find the partial fractional decomposition of x squared plus 1 over x times x minus 1 to the third. So we actually have what? We have a combination of type 1 and type 2. So we have x and x minus 1 are distinct linear factors, but then we have the x minus 1 that repeats. So this gets broken up, and I'm going to use A, B, C, D's instead of the A, 1, 2, 3 to maybe keep it a little bit clearer for us. So I'm going to have what first? Well, because it's distinct linear, all these get broken into their own. So A over x. Now I have the x minus 1 to deal with, but it's a repeating. So this is going to be B over x minus 1 plus C over x minus 1 squared plus D over x minus 1 to the third. And that's how many I have, so that's where I stop. And again, hopefully the A, B, C, D makes it a little bit clearer there. So now, just as in example 1 or type 1, I multiply everything by the LCD. So I'm multiplying everything by x times x minus 1 to the third. X times x minus 1 to the third. X minus 1 to the third. X minus 1 to the third, and x minus 1 to the third. So on the left, when I do that, what happens? The whole thing cancels out like it always should. So you get x squared plus, I'll just leave it as 1 for now, x squared plus 1. Over here, the x pieces cancel out, so I get a times x minus 1 to the third, plus one of these x minus 1s cancels with one of these, so I have 2 left. So b times x minus 1 squared. 2 of these cancel with 2 of those, leaving me 1 left over. So c times x minus 1. And all 3 cancel out, leaving me d times x. Dot, dot, dot. So now I'd have to expand this whole thing. FOIL this one, multiply by x here, so you get x squared minus x. Then has to get multiplied by c, and multiply this one out 3 times, etc., etc. Once you do that, and again, in the interest of time, you don't want to sit there and watch me just work through all this algebra and waste your time on video. So take my word for it, I guess. Trust me on this. When we expand all these out and then combine our like terms, you're going to end up with a plus b times x to the third plus negative 3a minus 2b plus c times x squared plus 3a plus b minus c plus d times x minus just a by itself. No other constant values. So as before, I compare all the coefficients. So I have an x to the third, and then I also have no x term here, so 0x plus 1. Excuse me, I don't know what happened there. So I have to compare all the coefficients with the values inside the parenthesis. So for x to the third, we get what? A plus b has to be the same coefficient as x to the third over there, that's 0. And then this one, negative 3a minus 2b plus c is equal to the value in front of x squared, which is 1. This one, 3a plus b minus c plus d equals the value in front of x, again 0. And then negative a has to be equal to positive 1. So constant equals constant on the other side. And then again, it's a matter of start solving this guy. This one actually isn't too bad because by substitution, we can say what? A here is equal to negative 1. Plug that back into the first one. So if a is negative 1, b has to be positive 1. Plug negative 1, positive 1 here. That's going to get you c is equal to 0. And then plug all of these three into the last one. Tells you that d is equal to 2. So therefore, our answer is that this original fraction ratio is equal to, again I'll switch to green so you have the answer here. We had what? A over x, which is negative 1, so negative 1 over x plus b, which is 1 over x minus 1. C is 0, so this term is gone. I don't have to put it in. And d is 2. So plus 2 over x minus 1 to the third. So this equals what we started with, x squared plus 1 all over x times x minus 1 to the third. So again, a lot of algebra. The key really falls into getting the things set up right. Once it's set up, the rest is a bunch of algebra, and then hopefully you don't make a little mistake along the way. So that's it. That's the second type where we have a repeating factor, a repeating linear factor in the denominator. Come on back and we'll look at type number 3.